up, what up? I'm the math teacher Goat, and today we're doing a full lesson on AP Precalculus. This is 2.14 Logarithmic Function Context and Data Modeling. So if you're thinking, wait a minute, didn't we do something like this in Unit 1 with linear and polynomial and stuff? You sure did. This time it's logarithmic, and it's equally as annoying. So, very heavy calculator section. And if you know me by now, I hate calculator stuff. And if you don't know me by now, you will never, ever, ever know me. It's a song from the 80s. Check it out. Notes are in the description. Please download them and follow along. Also, please like and subscribe. Thanks to, again, all the positive comments I've been receiving for this. Yes, these are free because I love ya. I should make them not free, though. Comment if you disagree with me. No one ever comments. Use a calculator. See, we're starting off strong. We're starting off annoying. Use a calculator to find when ln of x minus 3 plus ln of x plus 6 is greater than 0. So let's just go do it. All right, so we need to graph this guy, and we care about when this guy is greater than 0, which means above the x-axis, not including the x-axis, just above. So we hit y equals, we hit ln, which is right there, we hit x minus 3, we close the parentheses, we add ln, x plus 6, close it. And I care about when this is greater than or equal to 0, which is going to happen right around the 3 range. So why don't I just zoom in a little bit? Since I said 3 range, let's x min at like 2, x max at like 5, just to get a better picture. Why not? You know, in reality, what this does is this kind of like slopes down a little bit more, but the TI-84 pluses don't really do a great job showing that. I need to find out where it crosses the x-axis. Now you notice it only crossed the x-axis on one side. That's exactly what's supposed to happen. Second, calc, 0. I need to know when it crosses the x-axis. So if I hit right a little bit, it gives me the cursor just below the x-axis. So hit enter, hit right a few more times, hit enter again. And it tells us that y is 0 at 3.1097, so we'll do 3.120. 3.120, and that's going to be our guy. All right, so the magic number we got is when we graphed it. Okay, we get the log. That's the worst graph ever. Shows up like that. That number ended up being 3.120 after all the rounding and stiff. Okay, so what I care about is I care about everything greater than 3.120. Now, if you try to do this without a calculator, you're going to end up with some wonderful quadratic formula crap. We're using a calculator. It makes life easier. Now, the basis behind what we're doing is very similar to what we've done before. We've done linear, quadratic, cubic, and exponential regression. Now we are doing what's called logarithmic regression, which follows a lot of the same rules. So if I give you numbers in an XY format, you're going to hit stat, type those numbers in. Okay, so stat, edit, type those numbers in. The X values go into L1, the Y values go into L2. Okay, when you're done, you're going to hit stat, move over to calc, and go up a few times or whatever. I don't know which one's faster, but you're going to go to 9, which is ln reg, ln regression. Okay, logarithmic regression. Now, more often than not, when we do this, after we hit ln reg, we're going to want to use this equation for later. So the way that we're going to store our equation into the y equals button is we're going to go down to store reg eq, okay? We're going to let it blink. We're going to hit vars, go to y vars, and then function y sub 1. So vars, y vars, enter, enter, and this will store your equation into y equals 0 so that if we need to graph it or look at the graph, we will be able to do that. And that'll happen with the very next problem that we do. Okay. Now, once you're done that, hit calculate, and that gets you the equation. Okay? So we're starting out strong with a Mr. Bean problem. He's that silly guy that doesn't speak a lot. He started learning Chinese in hopes of translating all of his videos 1 year. Nice. He created some data to find a model for the number of days studying as a function of the number of words he learned that day. Okay, so these are my x values. These are my y values. What is a logarithmic regression equation that could model this situation? Okay, so that's just doing what we just did. How many days would it take for Mr. Bean to learn 100 words? So that's what would happen if we plug in 1,000 for x. Okay, and how many words would he learn if he studied for 2 months? Which means our, oh wow, that means our y is going to be 60. Ugh. This is going to be aggravating. I have a feeling that that's not going to work out for us, and we're going to have to come back and do a little bit of magic. Because this is logarithmic. I mean, logarithmic functions are going to look like this, and they're going to level out kind of quickly. So I have a feeling my calculator is not going to be super useful. We'll see. We'll see what happens. Let's do the logarithmic equation first. Let's see what happens when we do that. Okay, so stat, edit, and then we type in our x values, which is the top row. That's 10, that's 32, 79, 197, and 400. Okay, then we go over here, 1, 6, 10, 14, 17. So you can see the logarithmic behaviors. You see the x values exploding as the y values seem to go up by not so much every time. So that's, the logarithmic part made sense. Hit stat, go to calc, and we're going to do ln reg. So hit up a few times or down a bunch of times. I don't know if it really matters. But we want to save this because we're going to need this equation to do parts B and C. So I'm going to go to store reg eq. I'm going to hit vars. I'm going to hit y vars, and then hit enter, enter. Now once I go down to calculate, there's my equation. Negative 9.031. Okay, so the a is there, plus 4.351. No, 350. That was a close one. Ln of x. All right, so let's quick go back and write that down. Okay, so the equation that I got was y equals negative 9.031 and then plus 4.350 ln of x. So in order to do B, how many days would it take for Mr. Bean to learn 1,000 words? Just go back, plug in 1,000. We're going to have to do some calculator gymnastics, but that's what you do. So let's do it. All right, so now that that's taken care of, we need to find out what happens or how many days it would take for Mr. Bean to learn 100 words, 1,000 words. So we are in x, like our x has to be 1,000. Be very careful. If you were to try to do the calc value thing and do 1,000 now, it's not going to work because our graph only goes out to 10. So I can't plug in 1,000. So why don't I go to my window and let's make our x max, I don't know, 5,000. Okay, hit graph. Okay, so you see a little tiny chunk of it. Let's move our window up to like, I don't know. I mean, at some point we have to find 60 days, so let's just put it up to 60. And here's the issue already that we're going to see with C, but we're not going to talk about that this very moment because I care about what happens when I plug in 1,000. Now if I hit second trace to go to calc and hit value, I can type in 1,000, right? Hit enter, and that gets me 21.0, 21. And that's going to be our guy. Now I'm going to go back and I'm going to write that out. But before I start C, I notice a problem. C wants me to find out what happens or how long it's going to take me to get 60 days. 60 days is way up here. Way up here. So rather than trying to fix my window to a huge number, I'm actually going to go back and solve it. Okay, and then we'll use our calculator if I even need to use my calculator. In fact, I might be done with my calculator from here on out. But anyway, B it ended up being, what did we say? 21.021. So let's go. Oh, no way. It's actually 21.021, 21. It's like it's my birthday or something. Let's go back and write stuff down. All right, so when I did that, I got 21 days. And that's what we got. Now, the warning that I gave you about C, right, is that's the equation we got, like I knew would happen. Okay, but like 60 was way the heck up here. So something that is so shallow is going to take absolutely forever to get to 60. So let's just do the regular math using the equation that we got with A, and we'll ask Siri to do some of the gross math for us. Okay, so if I replace Y with 60, 60 is going to equal negative 9.031 plus 4.350 ln of x. In order to get x all by itself, we need to add 9.031 to both sides. That'll give us 69.031 equals 4.350 ln of x. Now we divide both sides by 4.350. And according to Siri, that gets me 15.869 is going to equal ln of x. Now, in order to get ln of x, regular x all by itself, we're going to base e both sides because that'll cancel you guys out, leaving me with just x. So running to my calculator, e to the 15, holy crap, 7,95054.094. So that is 7 million words. So apparently, Mr. Bean is going to learn all of Chinese in 60 days. What a gift. What a gift he has. But, yeah, that's how you do it. So you can see that I didn't really want to stretch my window in my calculator all the way to 7 million something. So there you have it. There you have it. All right. Now what? Oh, bacteria. A population of bacteria in a lab grows rapidly at first, but as resources become scarce, the growth slows down. Sounds logarithmic to me. After 1 hour, there is 500 bacteria. After 2 hours, 850. After 4 hours, population reached 1,300. Using this data, model the population growth over a time with a logarithmic regression and estimate the population after 6 hours. Okay, so I don't need to write out the equation. I'm just going to use my calculator to plug in 1, 500, 2, 850, 4, 1,300, and use that to then plug in 6 and see what we get. Okay, same exact thing. Stat, edit. We're going to type out 1 hour, 2 hours, 4 hours, and then we're going to move over and line 1 up with 500, 2 lines up with 850, and then 4 lines up with 1,300. Okay? Stat, calc, hit 9 for ln Ray. I don't know why I didn't say that before. I don't really care about the equation. I just care about using the equation. So I'm going to store regeq, vars, yvars, enter, enter. And then if I hit calculate, there's my equation. And again, I don't really care to write down. What I care about is what happens when it's at 6 hours. So I'm going to go to my y equals, make sure everything is there. I'm going to go to my graph, pretty steep, but I'm going to hit trace, second calc or second trace that allows me to type in the value of 6, hit enter, and then we get 1517.319, is it? My eyes are just so bad. I don't know, whatever that is. 1517.3183. So 1517.319. Let's go back and write that out. All right, the population is going to be 1517.319 bacteria. And I know we really shouldn't, put bacteria as a decimal, but you know what? Listen, man, it's just bacteria. What are they going to do? Attack me and eat my skin? A radioactive substance decays at a rate that follows a logarithmic pattern. After 1 year, 75% of the original material remains. After 2 years, it's 60, and after 4 years, it's 45. Use logarithmic regression to model the decay and predict the percentage of the material remaining after 6 years. So I will use 1 in 75. I don't need to worry about turning that into a decimal. Same types of numbers and using the same 6 as before. So thanks, ChatGPT, for being really creative and giving me some problems. Ugh. Let's go to our calculator. All right, same old, stat, edit. It was 1, 2, and 4 like it was last time, but this time our percentages were 75, so we use 75, and then 60, we'll use that too, and then 45. Okay? Just like last time, don't care about the equation, I just care about using it, so let's go to stat, calc, ln reg is 9. Okay, let's store reg EQ by going to vars, yvars, enter, and calculate. That's our equation. So then let's go to my graph. Don't see anything. That plus 75 would probably be the reason why. And then hit second calc, value, plug in 6, and we get 36.226. So that'll be 36.226%. 36.226%. Looking at these, I probably should have written the equations up because it did say model the population growth over time, but you saw me do it. So I'm not going to go back and redo those. I think we're okay. The average height of a certain species of tree in a forest can be modeled by that function right there, where h of x gives the height of the tree in meters, and x represents the number of years since the tree was planted. Based on this model, when is the first time the tree's height is predicted to reach 20 meters? So basically, I need that to equal 20. So what I'll do is I'll go into my calculator. I'll put that right there. And then in W2, what is this, taxes? In Y2, I'll do 20. I'm so stupid. Oh, I'm getting old. I'll put that there, and we'll find out where they intersect, and that intersect will give me the amount of years. Based on the model, though, when is the first time the tree's height is predicted? So, all right, so a little bit of stuff to be careful of. You know, we're not looking for decimals. No big deal. We'll be all right. All right, so just like I said, in Y1, we're going to type out 10.5 plus 3.8 ln of x. The other guy is going to be 20. So you're not going to see that if I hit graph because that only goes up to 10. So why don't we change the window and make the y max 25. Just so I can see just above the 20. Okay, now let's make our x max 15, and I think we'll be safe. All right, so right around there, whatever that guy is. So let's find out where they intersect by hitting second calc, hit 5 for intersect. Let's get all comfy close to it. Okay. And go just to the left of where they intersect, hit enter. Go just to the right of where they intersect, so right around there, hit enter again, and the intersection is going to be 12 point something. Okay, now dealing with no decimals, we're looking at 12 years. So, or during the 12th year is when that happens. So let's go back and answer that. So like I said, 12 point something meant during the 12th year, and that'll do it for that. Okay. Oh, I think we finally hit our first one where we don't need the calculator. Please, Lord baby Jesus, please. In a certain forest, the population of a species of deer in the year 2010 was about 5,000. The population increases at a rate of 4.5 per year, and the time is measured in years since 2010. Which of the following gives the number of years since 2010, t, as a function of population? Okay, so I don't think we really need to overthink this. Oh, except that we do. Okay, I see what we have to do here. All right, so first things first, we need to set up the regular population model. Okay, so the regular population model is going to be P equals your initial population, which is going to be 5,000. Okay, and then 1 plus our rate, which is 4.5%, so 0.045 to the t. And so that ends up being P equals 5,000, 1.045 to the t, and most people are going to be very happy with that, except they want us to solve for t now. Okay, they want us to solve for t. So the first thing that I'm going to do, that's the trick behind this problem, because I think most people would circle C and be like, that's not that bad. Unfortunately, it's not that simple. Let's divide everything by 5,000. Divide everything by 5,000. We get P over 5,000 is going to equal 1.045 to the t. Okay, now that's a lot of ln's. So I guess what we're going to do is I guess we're just going to ln both sides. So I'm all right with that. Let's ln both sides. Ln both sides. Okay. That allows us to then drop this t forward. So this ends up being ln of P over 5,000 equals T ln of 1.045. Divide both sides by ln of 1.045. Divide both sides by ln of 1.045. You cross out, and T is going to equal ln of P over 5,000 over ln of 1.045. Yuckity yuckity yuck. Gross, gross, gross. I don't like that one. But it's our first one without a calculator, so I can't hate you. All right. A scientist is studying bacterial growth in a lab. The number of bacteria in a culture is modeled by that equation right there, where n of t is the number of bacteria after 10 hours. How many hours will it take for the population to reach 1,000 bacteria? So basically, we want to set n of t equal to 1,000 and then solve for t. So 1,000 equals 200 e to the 0.12 t. Let's divide both sides by 200. No calculator needed yet. Okay, cross you out. 5 equals e to the 0.12 t. Now, in order to bring that t down, I have to ln both sides. So here's me ln'ing both sides. That allows me to cross you out. And so I have ln of 5 equals 0.12 t. To finish this guy out, we'll divide both sides by 0.12. And so now what I need to do is run to my calculator, find out what ln of 5 is, and then divide that by 0.12. So let's do that. Okay, ln of 5 equals that. Divide that by 0.12. We get 13.411. 13.412. So let's go back and do that. 13.412. All right. 13.412 hours. right. Last page. Thank God. The function g is logarithmic and the points 3, 2, and 9, 3 are on the graph. Which of the following could define g of x? So this is something as friendly as me running to my calculator and just doing ln regression. So let's do that. Oh, but you know what? Fun. It's written backwards. No big deal. Let's go back and do it. Okay, so stat, edit, we had 3, 2, so 3 enter, 2 enter, and then we add 9, 3, so 9 enter, 3 enter. We do want the equation, so let's go to stat, let's go to calc, let's go to 9. I don't need to store it, so we'll skip u for once, and we end up with 1 plus 0.910 ln of x. So we're going to choose the one that is the mirror image of, not the mirror image, but they want the a over here after the ln. So we will choose that when we go back. All right, so basically we had b just written backwards. No big deal. No big deal at all. The decibel scale is a numerical scale that uses base 10. Logarithms for measuring sound intensity. We've done a bunch of these before. Oh no, but we did Richter scale, not decibel. The larger the number, the louder the sound. As intensities increase multiplicatively, one of my favorite words ever, by a factor of 10, the decibel level increases additively by 10. Okay, so what that means is if somebody is 60 decibels loud versus somebody who is 70 decibels loud, that is actually 10 times more. That's what that's saying. Consider two sounds measured in 2023. A loud concert has a sound intensity of 90 decibels. Normal conversation is 60. Okay. Approximately how many times more intense was the concert? All right, so what we'll do is we'll do 90 minus 60. That's a change in 30. When we divide u by 3, okay, that means, not 3, when we divide u by 10, what that means is we get 3, so my brain's not functioning, and this is going to be 10 to the 3 times louder. And that would be 1,000. And we did problems very similar to it with the Richter scale. That is what that is saying right there. Ms. Rodriguez wants to save for a new luxury yacht. Good for you, Ms. Rodriguez. She currently has 80 grand in an account that pays interest continuously. Ooh, pert. One of my faves. And will need 5,000 in total. If she leaves her money in the account for 10 years and does not add anything, what interest rate would she need to achieve her goal? So here's the equation, okay? She wants to make 500,000, something I make in about a week. No, I don't. Please like and subscribe, watch my videos. And the principal is going to be 80 grand, okay, in an account. So that's going to be E. I need to find R, but she cares about 10 being T. Up. So I want 10R. 10R, 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 10R. All right. Let's do a little bit of math before we plug stuff in. Let's divide 80. Yep, I did that right. Looks like I just missed a 0, but that's still a big number. Let's divide 80 grand. I believe that would be 6.25. Yep, because it would be 40. Yep, 6 1/4. That's going to equal e to the 10r. Let's ln both sides to get rid of that e. Ln both sides to get rid of that e. U cross out. So 10r is going to equal ln of 6.25, whatever that is. Divide both sides by 10. Divide both sides by 10. We'll run to our calculator, find out what that is. ln of 6.25 divided by 10, and then we'll be done. All right, ln, there you are, of 6.25 is going to be that gross number. Then we'll divide that gross number by 10 and get 0.183. Okay, 0.183. So we'll try to explain what that means when we go back, and then we can finally be done, thank God. So R ended up being 0.183. That's my rate as a decimal, so let's move that guy over twice and say an 18.3 interest rate. Probably not going to get that anywhere anytime soon, but that's what Miss Rodriguez would need. And we are done. Ugh. If I haven't made it very clear that I absolutely hate calculator stuff, I do. Editing this thing's going to be a bear, so please like and subscribe. Leave positive comments. It goes a long way. Also, this was 2.14, so make sure you go to my YouTube and type out AP Precalculus 2.14 and further your knowledge with some of my random videos about this stuff. So, we're done. One more section in Unit 2. This is the penultimate, and then we'll be done for Unit 2. Thanks for watching. Bye!